YouTube freaks, do I ever have a special one for you? We're going to continue doing steady states. Today we're going to be doing... How ambitious am I feeling right now? You know what? We could make the argument that we would do BSS, CSS, KSS, and maybe then we do... Nah, we're sticking with those three. And guess what? After this, maybe I just stop doing the question. I leave you on a cliffhanger because the rest of these aren't that fun. And by that, I mean, it's just not very difficult. So you should be able to do it. You should be able to figure it out. Maybe. It kind of depends. I want to pivot away from this, though, because this is like my fourth or third video on the exact same question. And I know I could just make like a longer video or stop yapping for like 2 minutes before I start solving it. But, all right. So, BSS is equal to 0. This is because we have identical agents. I spelled that wrong somehow. I just know it. Identical agents. So, your bonds, I guess, maybe. I think this is the utility you get from bonds. This goes to 0 because they're trading perfectly efficiently and it falls to 0. So then all we need to do is CSS and KSS. So let's do that now. And I guess we're going to do tau as well. Tau SS. That's a terrible tau. Awful tau, but it's okay. So we know this is the case, but more importantly, we know this is the case. So RSS, and we know that RSS is a function of K, or is very involved, more or less. Oh, my writing's not very good today. And so we know that the function of KSS is equal to KSS, and I'm going to put it down there because the exponent is alpha. You can write it out like this, but that just doesn't look very good, you know? Like I've seen better notation in my day, so we're not gonna write it like that, although it is quite funny. You know, I guess maybe you could do that, but well, you know why I'm not. So this goes to the floor, and this is why I made this right here, is because you can mix it up. You can put it in the super or the subscript. Anyway, we're putting in this subscript today, although I have been doing superscript stuff. So you're just gonna have to let the inconsistencies not bug you. Okay. I think that's what I had here. Okay, so then obviously we have, because this we already figured out. Again, you might want to watch the prior episodes because I'm not explaining this stuff fully because I already went over it. So you'll have to look through it, my other stuff. But this is true. This stuff is true right here, okay? And we know this because of this. Because this is equal to, I guess I should write it out. You really don't. Why am I confused by this? No, I'm not. There. Did I geek out? Is that even true? No, that's completely true. Okay, so that's why. Because the 1 over beta and negative 1 over beta, negative n, 1 over beta, negative 1, you have this goes down here, and then this makes up RSS, okay? I don't know why that was such a, really struggling through that extremely simple algebra there. Really shows you how much I know. So anyway, but you're not using that one. You're using this one. So KSS alpha less 1 is equal to 1 over beta. And there's different ways of doing this. I'm going to show you the way I do it because I like that way. 1 over alpha. So you could do the thing where you put everything over alpha. I really like doing it this way, where I have 1 over alpha. It's the same thing. I just think it looks better. And I'm a freak for a looker. You know what I mean? Like they say looks aren't everything, and I agree with that, but they're definitely something, okay? And my girlfriend is proof of that because, she's gorgeous and she's also really fun to hang out with, but she's gorgeous, you know what I mean? And that definitely helps her out. That definitely helps her case out a lot. So anyway, we're going to divide this. I'll show you what I do here. This exponent goes away. 1 over alpha. 1 over beta plus 1. Yeah, she is in the room with me, okay? Yeah, I'm buying myself brownie points right now, okay? Like, stop asking. You know why I did that, you motherfucker. Guess what? It's also true. Yeah. I'm playing chess, not checkers. You guys wouldn't even get it. Anyway, that's your KSS right there. It's to the exponent 1 over 1 less alpha. I gotta edit out so much of that. Okay, so now we're gonna be doing tau because this is important, and it's the change, money price, the change, and this is equal to, and I guess maybe this is like a trust me moment, but I'd rather it not be. Or could I explain it better? Or should I just have it as a trust me moment? I think I'm just having it as a trust me moment. This is equal to this. You just have to trust me here. I'm not willing to explain it. And then, right? That's right. It's in the superscript. Okay, so there you have it. That's tau. And so this is important because then you can simplify the budget constraint, okay? So your budget constraint goes to, and if you remember what it looked like, it's going to look quite different. And I'm writing BSS. It is going to fall to 0. I can assure you that, but you just, again, please be patient. I'm not simplifying it just yet. It is going to be simplified. I'm writing the whole thing out so you know what it looks like. Not completely, actually. I'm doing whatever I did prior. I'm kind of just copying off my own stuff here. Okay. So this is what it is. This is falling to 0, so that's gone. And then also on that side as well. So you're left with this right here. And we know that this is alpha. Okay. And this is, I must see, okay. I was thinking of drawing out the whole line, but I feel like this is easy enough for me to just explain. So obviously this is 1 KSS. This is going to give 1, and then less sigma, I think? Delta? Don't quote me. Obviously this goes to the other side. These cancel out. So you're left with alpha less, I'm just calling this squiggly from now on. That's my boy squiggly. And then it goes to that right there. This is equal to CSS. So we're about to solve for CSS. And we've already solved for KSS because it's just up here. So Bob's your uncle. Why does this look different, actually? La 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 la. All right, guys, I found my mistake. I'm a little bit of a goofball. For some reason, I thought that, or I was just, whatever. I made a mistake. I literally just, I had this down, which is clearly wrong, because this isn't even the derivative. Like, this would be the derivative. I literally just had this. I had alpha k, which, like, you know, you see stuff like this all the time. Or, you know, something akin to that. But what I had was completely wrong. So, you know, we live and we learn. This is correct, and so that's why I had something different than what was correct, and I was like, what's going on here? Now I know what's going on here. So maybe I take my time with this, but it's unlikely. I think this is pretty easy. So 1 over 1 less alpha times alpha, that's essentially what's going on here, because it's to the exponent of. So this is 1 over alpha over beta. Don't forget all your brackets. My brackets are looking pretty bad tonight. You guys are going to have to let this one slide. Alpha over 1 less alpha. And then, oh, my foot, less squiggly. And then we're doing just the rest of it here. So 1 over alpha, 1 over beta. Less 1 over 1 less alpha. So your solution should look something like this. Hopefully neater, honestly. Like, please don't hand this in. I would hate to be your teacher marking this, but this is kind of what it should be. And that's it. We've solved steady states. I think that's the last one. Not really. Yeah. You're not solving MSS. I guess that's important. It's a constant. So that's why it's in the solution of, like, or in this model, in this situation, we take MSS as a constant, or we kind of just say it is, and that's why for tau, MSS is still there, and we also don't have like a explicit solution for MSS. We just treat it as a constant. So anyway, those are the steady states, and I will catch you in the next video.